So what we have in front of us here is a simple electrical circuit, and we've got the bulb here, we've got some wires connecting up, and what I've done is I've just put little magnets on the end here to make it easy to hook up into my battery. And we can see that when I hook up to the battery, I get it right, the light bulb comes on. And the wires that you can see on the diagram on the right are representing the actual wires in real life here. So you can see that what they're actually representing are these green wires here. And this is the bulb here. Now you'll see that in the electrical diagram I've got on the screen, the bulb looks like a little circle with an X through it. So anytime you see one of those little circles with an X on it, you know that we're talking about a light bulb. Okay. Now, the little line and the big line with the plus and the minus represent the battery here. And so this is what is being represented by that little symbol.
So what we have here is an LED and a resistor hooked up to the battery. Now, one of the things I said about the LED is it's called the light emitting diode. And one of the things about a diode is that it actually only allows current or electricity to flow in a single direction. And I can show you this by turning this thing around. So as you can see, we're going from negative, positive, and the battery's in this direction. But if I disconnect them, flip the batteries around, so I change the polarity, you see the magnet's right, and stick on there. And then what we see is that it doesn't light. And that's because this diode is actually blocking the flow of electricity through it. It only allows the flow of direction of electricity in one direction. There we go, lights back up. This is also a good time to introduce what's known as a resistor. Resistors are electrical components that have a very specific function. They're designed to limit the current, and they're also designed to work as ways of dividing up the voltage. We'll come on to that later on when we look at DC circuits. But right now, what this is doing is it's preventing this LED from becoming damaged. If this resistor wasn't here, so much current would flow through it that this LED would just burn up. So the next component we're going to take a look at here is the electrical motor. Electrical motors are devices that take electrical energy and convert it into rotational energy, or kinetic energy if you like. So basically what it does is you apply electrical energy to it and it rotates the shaft. Now this is really useful because we can use this to turn things. In industry we usually use this to turn things like pumps, but we can also use it to turn things like conveyor belts, elevators, lifts, and a whole variety of other things. Now, the other thing you'll notice that's slightly different is I've got rid of the battery. And the reason for that is that batteries, although they're very useful, tend to be a bit cumbersome and a bit of a pain to use. So what I have instead is my benchtop power supply. And so when you see cables like this, it's actually coming from a benchtop supply. And the benchtop supply puts out something called direct current, just exactly the same as a battery. So really, you can almost think of it as like an unlimited battery. And what I can do is I can hook that up to my electrical motor here. And lo and behold, you have a moving motor. Now what I'll do is I'll slow it down a wee bit. A bit more. And hopefully, you can see it moving. So, at such a low voltage, I can speed up. And eventually, we can see it working. So that is the electrical motor. The next component I want to talk to you about is the capacitor. Okay, capacitors come in a variety of different shapes and forms. This one, for example, is an electrolytic capacitor. Here's another one. You might find this inside electrical components. Here are these ceramic capacitors. And so they come in a variety of different forms. Now, the purpose of a capacitor is to store charge. And we're going to come and look at what charge is a bit later on in this section. But for right now, we can think of a capacitor as acting a little bit like a battery. They both store energy, But the difference is batteries can produce electrical energy through a means of a chemical reaction occurring inside the battery. Whereas capacitors can't do that. They can only be charged up and then discharged. They can't actually create any more electricity, so to speak. Now, the best way to sort of understand what a capacitor does is to see what effect it has on a circuit. Now, what I've got here is a breadboard with an LED connected up with a resistor in series, just like we saw previously. Now, what I've got here, about the breadboard. Breadboards are devices that allow you to easily connect up electrical components without necessarily having to solder them or wire them together. So for example, I'm able to plug this LED in straight into these two slots here. And the way the breadboard works is, in the middle here you've got these sort of groups of 5 holes, and they're connected along the way like this, or across the way I should say. So if I connect in something to that pin, then that is now connected to all the other holes in this little row here, all 5. There's a break in the middle where then these 5 are connected to each other, but only to each other, and that's it. And so each of the 5s are all connected to one another. The 2 columns at the end here, this one, and then these 2, they're connected along the way like this. And so they typically tend to be used as like the power supplies or the power rails. So for example here, what I've got my positive coming in from my benchtop supply, and it's connected onto a pin here, in this column. So because they're all connected underneath, it comes in, runs along, and then gets to this yellow cable. It can then go through the cable, down, and into this hole. And because this row is all connected, it goes here to this resistor, through the resistor, onto this row, then connects onto this LED, down here, up through the LED, down, into the row next to it, to this black cable, along, and to this pin. And when I hook it up, what we see is that the LED lights up. Now, what I want you to pay attention to is what happens to the LED when I disconnect the circuit. It instantly discharges, it instantly goes off. Okay, so I can touch it, comes on, goes off, on, off. So it's pretty quick. There's no delay there. Now, let's look at what happens when I hook up a capacitor. Now you have to be careful with capacitors, and I wouldn't recommend playing about with these at home. These type in particular, these electrolytic capacitors, if they are connected in the wrong polarity, i.e. if you connect the negative, which is usually denoted by a stripe here, to the positive, then they can basically explode, and we don't want these to explode. They can injure you and at the very least create a mess in your room. So I'm just going to blue tack it down, and what I'm going to do is I'm going to connect it into the circuit, like so. And it didn't explode, so that's a good start. Now at the moment, nothing seems to have changed. The light is still on, nothing's changed. The benchtop supply is still on, it's all good. But what I want you to pay attention to is what happens to the light when I disconnect this probe. Now it goes out slowly. Let's see that again. It comes on straight away, then it fades. Now that was different to before, because before the capacitor was connected, the LED would just come on and then instantly go out. And this really gets to what the capacitor is actually able to do. The capacitor is able to be charged and hold that charge. And in theory, we could charge the capacitor, disconnect the circuit, and as long as that capacitor never is shorted, it will remain charged. So now what I can do is come along and discharge the capacitor. So in some ways it acts a bit like a battery. It charges and discharges. The difference is capacitors can't hold as much energy as a battery. However, the difference between a capacitor and a battery is that capacitors can discharge much more quickly. They can put out a lot more current. We'll come to what that is later. So these guys can discharge much more quickly than batteries, but ultimately batteries can produce more electricity for a longer period than capacitors can. So in summary of today's video, we've looked at lamps, bulbs, we've introduced batteries, we've talked about wires and their purpose, we looked at resistors, motors, LEDs, capacitors and benchtop supplies, and we even introduced the breadboard. So what you want to make sure is that you're familiar with each of these components, their names and the electrical symbols that we saw in the diagrams. So check out the quiz below and test your knowledge.